Then we will solve a simple sum using a PSO. Then we will see how to handle some the integer variables in optimization. Then we will also see the constraint optimization problem. And finally, we will see the MATLAB programming execution for the unconstrained and constraint optimization problem. Okay, so first of all, let us see what is the meaning of optimization. Optimization is nothing but to find the best solution which either minimizes or maximizes a specific objective function while satisfying various constraints. We will try to get the concept of optimization by using a simple sum. Then this definition will get clear. So I have in this listed some of the applications of optimization methods. In general, nowadays, optimization methods or artificial intelligence methods are used in every field, whether it is a field of engineering or medical science or any field, right? Now, if this is the organizer is from the civil department, so first I have mentioned the application of optimization in civil engineering, right? You must have seen this concept. It is the optimal water distribution system in which we try to minimize the, it means we try to optimize the diameter of the pipe to minimize the losses of the water, or also we want to minimize the cost of the water distribution network. So this is nothing but the optimization problem. Similarly, in medical science, in CT scan, it is used in mobile phone dynamic programmings. In dynamic programming, the optimization is used. In stock market, the linear programming is used. Then in aviation system, the non-linear programmings are used. In the case of the electrical system, power systems, protection systems, power electronics. So I have listed only the some applications of optimization. Now, if you refer any journal paper of engineering discipline, then you can realize the fact that nowadays almost 60 to 70% papers are based on the optimization. Right, so this is quite interesting as well as challenging field, right? Okay. Okay, so later on we will formulate the optimization problem and we will try to solve a sum. Okay, now I start from the very basic mathematics regarding the optimization. See, optimization is a mathematical tool, right? It is nothing but the mathematics. Rather, engineering is a mathematics, right? In engineering, we model a particular system using the mathematical equations, and ultimately we solve those equations by using various numerical methods or optimization methods or classical methods, etc. Let's start from the beginning. Suppose I want to solve a particular problem, and I assume that, okay, first of all, let us see that simple sum. Suppose I have x square is equal to 25, right? So what is x? X is equal to plus or minus 5, right? So in this case, how many equations were there? There were only one equations. And how many variables were there? There was only one variable, right? So in this case, we get the unique answer, unique solution, that is x is equal to 5. Suppose I take another sum, that is x plus 5y is equal to 10 and 5x plus 25y is equal to 100. Right, so this is a two variable problem, right? It is nothing but the equation of a line. It is a line, right? This is also a line, equation of the line. Recall the basic mathematics, right? Okay, so that is x and there are two equations, right? So you can solve these two equations, right? by multiplying this equation by minus 5, right? So it is minus 5x minus 25y is equal to minus 50, and then you can solve these two equations, right? And you can obtain the solution, right? So in this case, there are two variables and there are two equations. So you will get the unique solutions of x and y, right? So in general, if the now I would say n, small n is equal to number of variables, right? And small m is equal to number of equations, right? So if a number of variables is equal to number of equations, then we will get the unique solutions. So if n is equal to m, then we will obtain the unique solutions, right? Now, you must have studied the Newton-Raphson method. In Newton-Raphson method, we solved a number of simultaneous non-linear equations or linear equations, right? So in Newton-Raphson method, the number of variables and number of equations are same. So you get the unique solutions. Of course, in some cases, there may be the presence of multiple answers. This is the different case. Okay, now let us proceed further. Suppose in this sum, suppose I add new equations. It means suppose I have written these equations, new equations: x plus 8y is equal to 10, 2x plus 4y is equal to 25, and 3x plus 7y is equal to 44. Now there are two variables, right? X and y, but there are three equations. So in this case, the number of equations m are more than number of variables. So if you solve these three equations, right? If you solve these three equations, then it is possible that you will obtain multiple solutions. You will obtain the multiple values of x and y, which will simultaneously satisfy this equation, simultaneously, right? So now there is a problem. We have obtained the multiple answers of x and y. We will obtain multiple pairs of x and y. So our aim is we want to find out which solution is the best solution among the possible multiple solutions. And yes, the process of finding the best solution among the multiple solutions is nothing but the optimization, right? So optimization is the process of finding the best solution among multiple solutions, which will either minimize or maximize a specific objective function. In most of the cases, the objective function is a cost function. We are interested in minimizing the cost, operational cost or maintenance cost, right? Or cost during the planning scenario. So we want to minimize the cost, right? So we want to minimize the cost or maximize. Suppose I want to maximize the social welfare. So in that case, the objective function is the maximization of the social welfare. So maximize a specific objective function is called as the optimization, right? So optimization is one step ahead from this case in which the number of variables and equations are same, right? Okay. So remember, when you find such type of scenario, it means when you obtain a number of equations more than a number of variables, then there will be the multiple solutions and you have to use optimization to find the best solution among possible multiple answers, right? And says yes, you may argue that I don't want to use the optimization. So then If you don't want to use optimization, then you will not obtain the best solution, right? And you cannot minimize the cost, right? So you have to use optimization. Okay, so this is the specific type of the objective function. Suppose the objective function is 2x1 square plus 3x2, right? It is a non-linear function because in this there is a x1 square, there is a square term, so it's a non-linear curve, right? Subject to these are the constant equations, right? So constant equation is what? X1 plus x2 should be equal to 6. It means your answer x should be such that if you do the addition in LHS x1 plus x2, then LHS should be equal to RHS, and RHS is 6 in this case. Similarly, there is another equality constant, there is equality sign. Your answer should be such that this LHS x1 plus x2 square, right? You will obtain the values of x1 and x2 using optimization, right? And the optimum, the obtained value should be such that this LHS should be equal to RHS, right? So, and similarly, these are the inequality constant because it contains the inequality sign. It means your LHS should be less than RHS, right? And this is the non-linear inequality constant because there is a x1 square term, right? So it's a quadratic function. Okay. And every variable x will have some minimum limit. Variable lies between its minimum and maximum limit, right? So in any optimization problem, when you get any variable, when you define any variable, then its minimum range and maximum range should be specified. It should be known, right? Okay. Okay, so now let us study the particle sum optimization method. Okay, that method was proposed by James Kennedy and Russell Albert in 1995 in one of the conference papers. Okay, so PSO is an artificial intelligence optimization method which has been inspired from the social behavior of organisms such as bird flocking and fish schooling. Okay, so now I would say that everybody is knowing the working principle of a particle swarm optimization. So let me try to explain the basic theory of PSO. And yes, I want to say that lots of improvements has been carried out in the basic PSO. Right, but today we will study the basic PSO and we will see those equations of PSO, and then we will try to solve this sum. Okay, so you this particle sum optimization method, it is called as, it is inspired from the nature, right? Now see, during the evening hours you might have observed. Hello, yes, have you, can you hear me properly? Hello.
Yes, sir. Yes, sir.
Okay. Okay. So during the evening hours, you might have observed the birds which are flying in the sky to find the food source, right? And you must have observed this specific pattern of the birds, right? There is a bird number 1, there is a bird number 2, bird number 3, 4, 5, 6, so on, right? Yes. So what are our observations? You must have observed that there is a one bird which is ahead of all the birds, right? So this is a group leader, It is a group leader, and it leads the whole group of birds, right? And I call this group of birds as swarm, right? And I call the bird as particle, right? Particle, right? So there is a group leader, right? And a group leader will change its velocity as well as direction, right? To find the food source, right? These birds are flying to find the food source. Okay, right? So there is a group leader. Also, every bird, every bird will follow this group leader, right? It means every bird will try to minimize the distance between its position and the position of the leader right? This is our second observation. Similarly, every two birds will try to minimize the distance between their positions, right? Also, these two birds will try to minimize the distance between their positions, right? So in a conclusion, all birds fly in a specific pattern. All birds are flying in a group to find the food source. So this is the behavior of the birds which is seen during the evening hours. And from this behavior, Professor Kennedy formulated the mathematical equations of PSO, which is used for the optimization. Right? Okay. Now we will try to solve a simple sum using a PSO, right? And we will try to see the mathematical equations of PSO. Okay. So suppose I have a objective function. This is x, this is y. I have an objective function f of x that is equal to x square plus 5x plus 10. I want to minimize this objective function, right? It means what? I want to find the value of x such that f of x gets minimum. This is our aim. This is the aim of optimization rather. We want to find out x such that f of x becomes minimum. So if you take the different values of x and if you draw the graph of f of x, that is y, then you will observe that this graph will exist in a second quadrant. Right? Like this. Right? So what is the point of minima? At this point x star, this f of x that is equal to y will become minimum. This is the minimum distance, minimum y. For any other x, right? For this x, the f of x is obviously higher than this minimum f of x, right? For any other x, for this x, f of x is more than this f of x. So this is the minimum value of the objective function. So our aim is to find this x star. This is known as the optimum solution, optimum answer or optimum solution, right? Okay. Again, I will draw the curve, but I will not draw the curve as per the dimensions. I want to just give you the idea. So it is not drawn as per the scale, right? So now suppose I draw a feasible region. Right now, we are talking about the mathematical equations, right? But eventually, we will compare our mathematics with the behavior of the birds. We will try to correlate all the things, right? Okay. So, suppose this is a feasible region in which the birds, various birds, are flying, right, to find the food source. So, assume that the food source is lying over here. This is the food source, right? In mathematics, this is the minimum value of the objective function, minimum value of f of x, which we had just seen before, right? This is the x star, and corresponding to x star, f of x, that is y, right? This is the optimum value, let us say. Yes, this is the x star. We want to find out this point, this x star, because it holds the minimum value of y. Assume that. Okay. So, in PSO, the birds, it means the particles fly in this region, right? Here and there, to ultimately reach to this source, right? So, okay. So now let us try to get the concept of PSO. So assume that I have considered the three particles. I am try to highlighting the concept of PSO, right? This is a particle P1, this is particle P2, and this is particle P3, right? See, what is our aim? We want to consider the x value, and corresponding to x value, we will find the f of x value. This is the basics of optimization, right? This is basics of any optimization, rather. Okay. So I have considered the three particles P1, P2, and P3. So corresponding to P1 particle, let us say the x1 is x value is x1. Corresponding to P2 particle, the x value is x2, and corresponding to P3 particle, the x value is x3, let us say, right? So initially I consider three particles in this case. So initially I assume these three x values. So x1 is this one, x2 is this, and x3 is this, right? So I assume these three x values, right? It means I assume three particles. I assume three particles, so three x values. Okay. So yes, simple. I have considered x values. So corresponding to x values, find out f of x values, right? So corresponding to x1, find out f of x1, right? There is an equation, f of x is equal to x square plus 5x plus 10, right? So x is replaced by, right? You can obtain the x value from here. Replace x value in this equation, x square plus 5x plus 10, so you can obtain f of x, right? So corresponding to x1, obtain f of x1. Now corresponding to x2, obtain f of x2, and corresponding to x3, obtain f of x3, right? Obtain x3, right? Okay. Now, using some rules, which we will see, using some mathematical equations, this particle, every particle rather, will move here and there. It means every particle will change their position, right? So assume that this particle has changed their position, and this is the new position of the particle P1. Let us say this was the original position at the 0th iteration. So I put P1 superscript 0, 0th iteration. All the optimization methods are the iterative methods, right? And in every iterations, we will update the solution. We will update the value of x so that the function value gets better and better. It means function value gets minimum and minimum in every iteration, right? So this is P1. This is the value of a P1 particle at the iteration number 1. Now we assume that P2 has changed to this new position, and this is the P2 superscript 1. This is the value of X of a P2 particle at the end of first iteration. Similarly, P3 is changed, right? Some heuristic rules, and this is the P3 superscript 1, right? Okay. So we have updated the positions of every particle, right? Now the same procedure corresponding to this, the x1 value corresponding to particle 1. So it is x1 superscript 1, right? x1 superscript 1. Find out the f of x1. Find out f of x. Similarly, x2 superscript 1. P2, you can find x2 superscript 1. Find out the value of objective function f of x1, f of x2 superscript 1. Similarly, x3, you can find out the function value, right? Okay. So in the first in the 0th iteration, we have obtained these functions values, and in the first iterations, we have obtained these functions values, right? Now, what we do? Now, for every particle, suppose the P1 and P1, compare the function value P1. So this is the function value in the 0th iteration for the particle P1, and this is the function value of the particle P1 at the end of first iteration. Now compare this value and this value. Which one is minimum? Find out which one is minimum. Suppose from this one is minimum, then the corresponding x value is known as the personal based, P based, or it is called as the personal based position, right? What is the meaning of personal based position? Personal based position means we are comparing the function value of the each particle, right, and corresponding to the minimum function value, the x value is known as the P based value, right? And this concept in PSO is known as the personal memory. It means we are moving towards the based memory, towards the based personal memory, right? So this concept is known as the personal memory, or it is also called as the personal intelligence, right? So this is the first concept. Now the second concept is group intelligence or group memory. Same concept. I am considering the three birds, right? P1, P2, and P3. Right, in 0th iteration, I obtain f of x for every particle. Similarly to the previous case, this f of x1, f of x2, f of x3, right? Now, using some rule, as I mentioned earlier, it means every particle change its position. So this is the new position of particle P1 at the end of first iteration. Assume that this is the new position of particle P2 at the end of first iteration. This is the position of new position of the particle P3 at the end of first iteration. Right now, okay. Now in zeroth iteration, we will compare all these functions values. We will compare the functions values corresponding to every particle, particle 1, particle 2 and particle 3, and we will find out which particle gives the minimum value of f of x. Right? So suppose, hypothetically assume that this particle gives the minimum value of f of x. Then in the zeroth iteration, this particle is called as the global based particle. Global based particle, or it is also called as the king particle. It's a king particle, and in case of a genetic algorithm, this is called as the elect particle. Elect particle, because it holds the minimum value of the objective function. It is a king particle because it is the best among all particles. Right now, in the first iteration, right, using some rules, this is the updated positions of each particle, and corresponding to each particle's x position, we will obtain the f of x, right, f of x1 at the end of first iteration, then f of x2 at the end of first iteration, f of x3 at the end of first iteration, right, for particle 1, 2 and 3. Now same procedure, find out, it means compare the functions values which are obtained in the first iteration. So compare f of x, this and this, and find out which one is the minimum in this group. Hypothetically assume that this is the best, this is the minimum value, f of x3 is the best. So in this first iteration, this is the king particle, this is the king particle. Now, yes, compare the global based particle which is obtained in the zeroth iteration and the global based particle which is obtained in the first iteration. So compare f of x2 which is obtained in 0 iteration and f of x3. Which one is minimum? Find out. Which one is better? So suppose this is better, this is lesser than this, then in the subsequent iterations, this particle P3 will be considered as the king particle. It will be considered as the global based particle. Because it is based of base particles, based of the remaining particles. Right? So every particle will follow the king particle or the base particle. So this concept is known as the group memory, and it is called as the group intelligence. Group intelligence. Okay. Now the third concept. As I told earlier, every bird moves here and there to find out the food source. Okay, so ultimately every bird will reach to this point. It means this is the x value, right? In every iteration we are updating the x value, or rather in other words we can say that this is the step length, this is the new position, this is the old position, and this is the nothing but the step length. This is the step length. So yes, so in initial phase the step length should be high, and ultimately decrease as you move towards the optimum solution. And when you reach to the optimum solution, your step length should be obviously 0. It should be obviously 0, right? So we are introducing this concept, and this concept is known as the inertia constant. Inertia, and it is designated as omega, right? And this inertia constant is a fraction, it is less than 1. So in every iteration we are multiplying this inertia with this step length, right? And we are decreasing this inertia value. Let us say from point 0.9, then 0.8, then 0.7, and up to 0.3. So, right, suppose as you hypothetically assume that your step length was 1 initially. So, initially W into 1, right? This was the and to 1, right? Then you are decreasing the W, right? And ultimately W will become equal to 0.1, right? Ultimately the step length is decreased. So remember, this inertia constant of this concept is also used in many optimization methods. In short, in initial phase the step length should be large, and as you move towards the optimum solution the step length should be decreased. So now using these concepts we of a PSO. Okay, so things which I had discussed earlier, right? Okay, so now this is the equation of the PSO, right? So in PSO we are initializing the x value of the variable, and we are also initializing the step length of the variable, right? So this step length is nothing but the velocity. See, this velocity term is slightly misleading, right? In book velocity is written, but velocity is nothing but it is a step length of x. So step length of every particle, I means particle number, right? And k is the iteration number. So velocity of every particle in k plus 1 iteration, it is equal to w into vik. This is the inertia into velocity, it means step length, which occurred in the kth iteration, right? This concept is similar to this one which I discussed here. And then this is c1, it is a constant, positive constant, whose value is taken as 2.1. Of course it lies between 0 to 2.5 or 2.1, right? It's a constant. Then rand1, it is a random number which is generated between 0 to 1. Then p based I, it means personal base position of the I particle, minus xik, it is the current position of the particle. So current position of the particle is subtracted from the personal base position of the same particle, right? This is nothing but, this second term is nothing but the personal memory, personal intelligence. Every bird tries to follow its past based position, past based memory. Then this third term is known as the group intelligence or group memory, right? The equation of C2, it is a constant. Then random 2, it is also a random number which is generated between 0 to 1. This is G based. This is the global based position. It means the x value of the global based particle minus current position of the particle. So current position of the particle is subtracted from the global based position of the particle. So this first term, this second term, and this third term are added together to determine the step length of every particle. And once the step length of every particle is determined using equation number 4, it means new position of the particle will be equal to, it means xik plus 1, new position is equal to the position of the ith particle which occurred in the kth iteration, which occurred in the just previous iterations, plus this vik plus 1, it is the step length which we obtain using equation number 3. So you are updating the value of x to minimize the specific objective function. Okay. So now let us see the sum. Okay, as I told earlier, in this case, we will minimize the objective function, that is x squared plus 5x plus 10, and x lies between its minimum value and maximum value. In this case, I have considered minus infinity to plus infinity, right? Right. So yes, the graph of this function is this, right? So initially we will assume the values of x, right? We will assume the number of particles. Now let us solve this sum using PSO. So in this case, I have considered the 5 particles. It means I have assumed the 5 values of x, right? This is a small scale problem, so you can assume 5 particles. But if it is a large scale problem, then you can assume higher number of particles, such as 50 or 100, right? And yes, if it is a very large scale problem, then also you can assume 100 particles. And if you consider 100 particles, then you will get the answers with sufficient accuracy. So generally we don't assume more than 100 particles, otherwise the computational burden will increase. Okay. Now, so in the first, in the zero iteration, in this case, I have considered 5 particles, and I assume the initial value of x. This is called as the initial guess. Initial guess. This initial guess is a common step, first step for almost all AI methods. You have to initialize the value of x within the minimum and the maximum limit. Okay, so in this case, corresponding to first particle, I have assumed this x value minus 3.75, for second particle minus 3.5, for third particle minus 2, then minus 1.5 and minus 1. I have taken negative values. You can also consider the positive values, no problem, right? I have randomly assumed these values up. Okay. Now, for each particle, you have to assume the velocity. It means you have to initialize step length, or you have to guess the step length, right? In this case, for every particle, I have considered the step length as 0.05, 0.05, 0.05, 0.05. I have taken the same values, right? But as per the rule, thumb rule rather, you have to use this equation. Velocity of the particle will be equal to 20% of upper bound of x minus lower bound of x, right? A lower limit are given, upper limit is also given. Take the subtraction and take its 20% value, and that will be the initial velocity. But I have not used that equation in this because it is a small scale problem, so it won't affect the accuracy. But for large scale problem, you have to use this equation. So we have also initialized the velocity. It means step length, right? Okay. Also, we are creating the base case values, right, at the 0th iteration. Then, okay, now once you have obtained these x values, now find out the f of x. Simple. Okay. And for the simplicity, I have assumed that constant C1 and C2 is equal to 1, and randomly generated number R1 and R2 are also 1. It is just for the simplification, right? But in a practical case, these R1 and R2 are randomly generated, and you have to write the computer program. Of course, we will see the MATLAB coding. Okay. Yes, I want to highlight that point. Yes. See, as I told here, this is the random number, and this random number generated is multiplied with this subtracted value. It means this random number will determine the pulling of this particle towards its personal best position. If a random number is 1, then the maximum pulling. And if random number is 0, then 0 into this subtracted value, so 0. So there is no pulling. So this randomness, random number determines the pooling, a degree of the pooling of the current position with respect to the personal based position. And as the randomization is introduced, such methods, PSO method, is called as the heuristic methods, or rather meta heuristic methods. Meta heuristic. Why meta heuristic method? Meta means many. We are creating many particles, so it is the meaning of meta. And heuristic, because we are introducing the concept of randomness. We are introducing the concept of randomness, right? So PSO and genetic algorithm, artificial bee colony methods, all are called as the meta heuristic methods. Okay. Now, yes, this is the 0th iteration. So x0 values are assumed. These x0 values are also called as the personal based x values, personal based position. Position means x values, or it is also called as the p based values, x values. Why? Because this is the 0th iterations, right? So x value and p based values all are same, but in subsequent iterations they may get changed once we do the comparison, right? Okay. Now we have initialized the x value. Now find out the function f of x. So fp based, it means functional personal based value of the first particle at the end of 0th iteration, right? It is equal to x square plus 5x plus 10. X is value minus 3.75, right? X square plus 5x plus 10. So you obtain 5.31. And then functional personal based value of the second particle at the end of 0th iteration, it was minus 3.5. So minus 3.5 square plus 5x plus 10, so 4.75, right? Similarly for third particle, fourth particle, and the fifth particle. Okay, now simple. Now here there are 5 particles, so there are 5 functional values. Now find out which function value is minimum. This or this one. So minimum function value is 4. So in the end of 0th iteration, which one is the king particle? Think, which gives the minimum value of objective function? So this gives the minimum value of the objective function. So this is the king particle at the end of 0th iteration. Which particle? First, second, and third. Third particle is the king particle. So I will call these third particles index. Index means roll number. Roll number of the king particle is what? Index is 3. Roll number is 3. Index is 3. What is the x value corresponding to the global based particle? X value is minus 2. So G based means x value. X value of global based particle. And what is the function value? F G based. F means function value. Function value corresponding to global based particle, it is 4. So at the end of 0th iteration, we obtain these values, right? Now we will use equation number 3 and 4 to update the x values of each particle. Then we will make the comparisons and we will update the global based particle as well as personal values. Okay. Now using equation 3 and 4, right? So k is 0. So vi, it means v1, it means first particle. K is 0. So 0 plus 1, 1. So velocity, it means step length of the first particle at the end of first iteration. It is equal to omega into vik, right? Omega inner step constant 0.9, vik, v1 superscript 0. What was the velocity of the first particle in the 0th iteration? See this table, it is 0.05. So 0.05 plus C1 R1, both are 1, 1. Then personal based position of the first particle, right? So what was the personal based position? This minus 3.5 was xi, current position of the first particle at the end of 0th iteration. So x1 superscript 0. So what was the x value? This is same, minus 3.75. So minus 3.75 plus C2 R2 both are 1 1. G based, what is the global based? G based x values. So minus 2, it is minus 2 minus current position. These and these are same, so it is minus 3.75. So ultimately the velocity, it means the step length of the first particle obtained is 1.795, right? And after obtaining the velocity, you can obtain the position. So position of the first particle at the end of first iteration, it is equal to what? It is equal to previous position, that is a x1 superscript 0, right? It was this minus 3.25 plus lambda. It is a constriction factor. It is a constant which will affect the convergence. It is considered as a constant, right? And this is v1 superscript 1. So it is a 1.795. So this is the new value of a particle 1 at the end of first iteration. It is minus 3.2115. So use the equation number 3 and 4 for the remaining 4 particles, right? And I have tabulated the newly updated position value of every particle at the end of first iteration. So right, so these are the updated values of x, and these are the updated values of the step length or velocity. Okay, now same procedure, repeat the same procedure. You have obtained new values of x. Now find out the corresponding values of f of x, and then we will carry out the comparison. Okay, so now find out the values of f of x and put a is equal to 1, right? So functional personal based value of the first particle at the end of first iteration, right? It is x1 superscript 1 square plus 5, x1 superscript 1 plus 10, right? So functional personal based value obtained is 4.2563. Then for the second particle 4.0378, for the third 4.01, fifth, no sorry, fourth 4.49, fifth 6.94. Now the same procedure, 5 function values are obtained for the k is equal to first iteration number 2, or k is equal to 1. Now tell me which one is the minimum among these 5 values? This one is the minimum, right? So in this iteration, what is the global base particle? Third is the global base particle whose index is third, roll number is third. Minimum value of f of x is 4.01, and corresponding to f of x, what is the x value, g based value? What is the g based value, right? It is the, right? Now we have to compare the values which we obtain in this iteration with the values we obtain in the 0th iteration, right? We obtain in the 0th iteration with these values. In the 0th iteration, which was the global base? This was the global base. The value of function values was 4, and in this case the value of function value is 4.01. so which one is better? This one is better or the previous one was better? The previous one was better, right? Previous one was better. So corresponding to previous one, g based, which was the g based x value was minus 2. So in the next iteration we will consider g based as minus 2 and not g based x value corresponding to 4.01, right? So I have tabulated these facts. This is the particle number 1 2 3 4 5. This is the function values when x when k was equal to 0, it means 0th iteration. These were the x values in the 0th iteration. This column shows the function values in the end of k is equal to first iteration. This is the x values at the end of first iterations, right? So now compare these function values with these function values, right? For determining the personal based values, right? So 5.31 and 4.25, which one is better, which one is minimum? This one is minimum. So new functional personal based is 4.25, and corresponding to new functional personal based, which is the x value, this is the x value, so minus 3.2115, it is the new personal based, new p based for the first particle. So we have updated the personal memory, in other words. Similarly, for the second particle, compare this and this. Which one is minimum? 4.03 is minimum. So corresponding to this, which is the x value? It is minus 3.03. So new personal base for the second particle is this. Now for the third particle, compare this and this. Which one is better? This one is better, which occurred in the 0th iteration. So in the subsequent iteration, it means in the next iteration, this 4 is considered as the functional personal based value, and corresponding to this x value is minus 2. So for the third particle, new personal based x value, personal memory, is minus 2 and not 4, not 4. Remember this. For the fourth particle, again this one is better. So corresponding to this is personal based. And for the sixth particle, again this one is better. So minus 1 will be considered as the p based particle, right? So for third and fifth particle, the p based is personal based is changed, right? Okay, so now we have obtained the best functional values at the end of first iteration, second iteration. So now compare all these function values. Which one is minimum? This one is minimum, 4 is minimum, third is minimum, and corresponding to this, which is g based? G based is minus 2. So in subsequent, in the next iteration, we will consider g based as minus 2. Okay, so again using equation number 3 and 4, we will update the velocity of the first particle. So it is a v1 superscript 2, right? So omega into v1 superscript 1, it is 1.79 plus c1 r1 11. Then x1, it is the current position of the particle, right? So what is the current position of the particle? Minus 3.2115 minus, it is subtracted from the personal based position of the first particle, right? So what is the personal based position of the first particle? It is minus 3.2115, okay, plus c2 to 11. Then again current position is subtracted from the g based particles position. So what is g based at the end of iteration 2? G based is minus 2. So minus 2. So you obtain new step length is this, and new position, it is equal to current position at the end of first iteration plus so new position of the first particle. So apply this rule for the remaining all particles, and you obtain the new values of x, right? So this is for the third particle, then this is for the fourth particle, similarly for the fifth particle, etc. Right? For the fifth particle, you will obtain this, and then I have tabulated new positions and velocity of the particles. So in the next iteration, again use these x values and find the function values, and again compare these values with the values which we obtain in the last iteration, and the same procedure is repeated until we get the solution. So this is the iterative method, right? And then again at the end of third iteration, I have tabulated these facts. Right, again compare this value with this one. Which one is minimum? This one is minimum, so consider this. And corresponding to this f of x, which one is x value? So right, so you consider that x value as a new p-based value, right? I have provided the ppt, so I would encourage you to do the hand calculation and cross check your results with these obtained values. Then you will get the confidence. Again I have listed some calculations for the iteration number 3, 4, etc. And ultimately at the end of 200 iterations, so you will obtain the g-based value as a minus 2.5 and corresponding f of x value as a 3.75. Okay, so now the question arises, up to how many iterations we should carry out the simulation, right? So convergence criteria tells us up to how many iterations we have to do the calculations. So convergence criteria are this: if based k plus 1 minus fg based k is less than or equal to 10 raised to minus 5, it means if you don't find the improvement in the base value of the function values of the global based particles, then you can stop. It means the two consecutive function values of the global based particles are almost same. It means the difference is very near to 0. Then you can stop. Or else, if the global based particles x values in two consecutive iterations are almost same, it means the difference is almost 0. Then stop. Or else you can carry out the number of functional evolutions, that is equal to number of particles into the number of iterations which you defined. If this product you have to define, suppose I defined this product as 5,000 or 10,000 or 50,000 or 1 lakh, right? Then if a 50, typically if I take the number of functional evaluations as 50,000, so if 50,000 functional evaluations are carried out, then you can stop the simulation and the final answer obtained is considered as the best answer. Okay, so now in a case of optimization, in many cases we have to handle the discrete variables, right? Discrete variables are the variables which occur in the steps, right? Between the two steps you cannot take its value. So in optimization you can use this equation to convert the continuous variables into the discrete variables or integer variables, right? So it is equal to yg actual value is equal to minimum value of that discrete variable plus rounding, then there is a continuous value of the variable minus its minimum value upon the defined step length. Step size is defined for that particular discrete variable into the step size, right? So suppose I assume that I have one variable, it is known as the taps, right? Which occur whose minimum limit is minus 95 and maximum limit is 1.05, and it occurs in the steps of 0.025. It means their possible values are 0.95, 0.975, 1.025 and 1.05, right? So suppose in optimization I obtain its value like a 0.99, then I have to convert this continuous value into the discrete value using that this equation, right? So it's actual value, resultant discrete value, it is equal to minimum value plus rounding, actual minus minimum on step which is step 0.025 into 0.025. So ultimately you will obtain this resultant value as 1. Right, so this equation can be used. Okay, now in the optimization, the any optimization consists of the various constraints, and that problem is known as the constraint optimization problem. It may consist of the equality constraints as well as the inequality constraints. Now the problem is how to handle the equality and inequality constraints. So we are formulating the penalty function method, and that function is known as the augmented objective function. That is equal to what? This capital F of x is the augmented objective function. It is equal to original objective function. In our case, it was x squared plus 5x plus 10 plus alpha. It is a constant. Then violation in the constraint equations, and its square plus beta, it is also a constant, and the square of the violation of the constraint inequality constraint sum. Yes, I always give this simple example. Now you are familiar with the case of the library, right? How to handle the constraint, that I want to highlight. In case of library, what is the constraint? I have tabulated number of days and the penalty on this column. If you submit your book within the 14 days, then the penalty is 0. If you submit your book within 14 days to 21 days, the penalty is ₹5 per day. It means if I consider this as a constraint, if you violate your constraint, you are imposed the higher penalty. If you submit your book in third to fourth week, then the penalty imposed is very high. And if you still submit your book in 25 to 28 to 35 days, then very, very high penalty is imposed. It means higher the constraint violation, higher the penalty, right? So what is the meaning of constraint violation? So constraint violation is nothing but, suppose I write this equation 3x1 plus x2 minus 3. It means your optimum x value, x1 and x2, should be such that when you replace x1 and x2 by those obtained optimum values, then this LHS should be equal to RHS. It means LHS minus RHS. Take this on left hand side. LHS minus RHS should be equal to 0. Right? So constraint violation is nothing but the LHS minus RHS of the constraint. And this difference should be very near to 0, or in a perfect sense, it should be. So constraint violation is this minus RHS, right? So in case of equality constraint, what is the constraint violation for this case? LHS minus RHS, and take on this side, minus 0 is equal to 0. So constraint violation is nothing but 3x1 plus x2 minus 3. So in the case of objective functions formulation, so this equal to old, it means original objective function plus penalty coefficient into square of hi of x. This is the equality constant and its square. Why we square? Because we want to impose a very, very severe penalty for even a small violation in the constraint. Remember, the constraint should not be violated in any case. That's why we are putting the square, right? And we are also multiplying this violation of the constraint with a very, very high positive coefficient. It is known as the penalty coefficient. Generally, it is taken as 10,000, right? And for the inequality constraint, this is the inequality constraint, minus 4x1 minus 3x2 plus 6 should be less than or equal to 6. So we can put the if else loop. If this LHS is more than 0, then the constraint is violated, right? Then put the constraint violation, and it is a 1000 or 10,000 into violation square. It means LHS minus RHS whole square. This minus 0. So put this whole square. And so if it is more than 0, this violation square. Else it is less than 0, then no violation. Then penalty function is 0 because there is no violation. Right? So for inequality constraints, we will put if else loop. So using a penalty function, we can handle the constraints. Okay. Now again, I have considered the two particles. I have hypothetically taken this case, two particles, right, in constraint optimization. Now first particle has a some function value, right? Let us say its a function value is 10,000, but its violation, constraint violation is 0. Whereas second particle, its function value is 3,000 only, but its constraint violation is 1 lakh. So what is the augmented objective function value? F of x2, it is 1 lakh plus 3,000. And in this case, f of x1 is only 10,000. So which one is minimum out of this? This one is minimum. F of x1 and f of x2, it is minimum. Because its constraint violation is 0. In actual sense, this function is better than this. But as the constraint violation is very, very high as compared to this particle, if you compare these two particles, then this one is better, right? This is the importance of the penalty function. So I have considered this minimization of a 2x1 plus x2. It means this sum, right? 3x1 plus x2 minus 3 is equal to 0. Subject to minus 4x1 minus 3x2 plus 6 should be less than or equal to 0. And this x1 plus 2x2 minus 3 should be less than or equal to 0, and x1, x2 should be greater than or equal to 0, right? So I formulate this augmented objective function. This is the original objective function. This is 1000 into equality constraints violation square plus 1000 into inequality constraint violation square. So ultimately you will obtain this answer: x1 is equal to 0.6, x2 is equal to 1.2, and f of x is equal to 2.4. So this is the list of references. Now we will see the MATLAB code, right, of these two sums. And also I would like to mention the concept of no free lunch theorem. It means this theorem tells that there is no single algorithm which can excellently perform for all test cases. It means suppose you have invented 5 algorithms and I have invented 5 algorithms. So it may happen that your 5 will outperform my 5 algorithms for specific amount of test functions, and for remaining test functions, my algorithm will outperform your algorithms. Right? In short, the average performance of all algorithms, or in other words, this is the standard statement. There is no algorithm which will perfectly perform for itself, right? As a result, as in the initial phase, it was mentioned that I have won many optimization competitions of a smart grid optimization. So in a smart grid optimization, every time the different optimization problems are imposed to solve, which are to be solved by the participants, and every time we have to try for the new optimization methods, because some in one case I proposed EVDP, so enhanced velocity particle sum optimization. It could not perform well for the optimum bidding case, and in that case I had to propose and I had to try for another algorithm, and it was the covariance metric adaptation evolutionary strategy. Right, so this is the area of a large research. Right, now we will see the MATLAB code of both these sums. Okay, so this is the sum in which we want to minimize f of x is equal to x squared plus 5x plus 10. This is the MATLAB code. I have initialized the swarm. I had considered the 10 particles. I had taken the range from -5 to 0. Initialize the velocity. right? So now I run this problem. Hello. Hello, sir. Yes, sir. Okay, can you hear me?
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you.
Sir,
So
hello,
I
sir.
have run.
Can you
Yes.
just maximize? Can you we can't to screen just maximize?
Yes. Now can you see this? I have maximized it. Can you see this now?
Yeah, little. Okay, sir. Okay, sir.
Okay. I will email you my codes if you want, right? So this is the MATLAB code, and I have this sum. Okay. So yes, I had initialized these 20 particles. So these are the final values, x values of the particles, right? So base value of the function that is obtained is 3.75, and this b is the index of the base particle. So third, sorry, this one, sorry, this one, yes, or else I again run this. Yes. So minimum value of the x value is minus 2.50, and base value of the f of x, that is a 3.75, right? And the index of the global base particle is 5, right? So fifth particle, 1, 2, 3, 4, and 5. This fifth particle is the base particle, which gives the minimum value of the objective function. So this is the case of unconstrained optimization. Now let us see the constrained optimization. PSOLP with penalty. Yes. So in this case, I formulated the this objective function, right? 2x1 plus x2 plus this is the equality constraint, right? Equality constraint square, then a penalty function plus a penalty function 1. So these are the constraint. If minus 4x1 minus 3x2 plus 6 is greater than 0, then penalty is 1000 into minus 4x1 minus 3x2 plus 6 whole square. Else, if a penalty, if a no constraint violation, then penalty is 0. So using this, we are handling the constraints, inequality constraint. This is the second inequality constraint. If x1 plus 2 x minus 3 is greater than 0, then penalty function 1, it is 1000 into x squared plus 2x2 minus 3 whole square. Else, no constraint violation, so penalty is 0, right? So both these constraints are added in the objective function. So this is corresponding to the inequality constraint, this is corresponding to the equality constraint, and this is the original objective function. Okay, so now let us run this sum. This is the two variable problem, right? So this first column shows the values of x1, and this second column shows the value of x2, right? So in this case, I must have taken 100 particles. How many? Yes, I have taken the 100 particles. So these are the values of 100 particles, right? And best values of x1 and x2 is 0.6 and 1.2, and b is 16. That is the index of the global best particle. It means 16th number particle is the best one. It is 0.6 and 1.2, and the best value, it means the function value, is 2.4. Right? So this is the constant optimization using a PSO. Okay, so this is all about the application of PSO in unconstant optimization as well as the constant optimization. So this is all about the PSO. So if you have any query, you can ask me, or you can email me if you wish.
Sir, I have 5 questions, very small questions.
Yes, yes.
Sir, first of all, I want to know about the difference between heuristic and meta-heuristic.
Yes, heuristic means when we add the concept of randomness, right? In updating the value of x value, it means when you want to update the position or step length, and if you multiply the step length by the randomly generated number, then that concept is known as the heuristic. You are introducing heuristics in your optimization. And meta means many. When you consider the many solutions in PSO, we are considering many solutions. In this case, I have considered 5 particles. So I have considered five initial solutions. I am updating 5 solutions every time to get better and better answer. If I in the last sum I had considered 100 particles, right? I had considered 100 possible solutions to obtain the better and better answer. That's why this PSO method is called as the meta heuristic method. And in most of the AI methods, almost all AI methods are the meta heuristic methods. You are dealing with the multiple solutions. You are dealing with the multiple possible solutions, right? So as such, all AI methods are meta heuristic methods, right? But
Okay, sir.
if you consider only one particle, right, then you can you cannot consider that method as a meta heuristic methods, because you are dealing with only a single solutions. And recall the fact that in classical methods like steepest descent methods, in Newton's methods, in the conjugate gradient methods, you are dealing with only a single solutions. So those methods are not called as the meta heuristic methods, and also they are called as the derivative based methods. They are also called as the classical methods, right? So in short, yes, in one case, in a variable neighborhood method, once upon a time I had used only one particles. So at that time I can call that method as simply a heuristic method, not a meta heuristic method. Is it clear?
So isn't it heuristic method is something like deterministic method?
Heuristic methods and
Deterministic.
no, in deterministic methods using the derivative informations to update the step length. We are carrying out the first order partial derivative of the objective function, or we are carrying out the second order partial derivative of the objective function to update the solutions. That's why the classical methods are known as the derivative based methods.
Okay, sir.
So in
Sir,
in heuristic methods, we generally don't use the concepts of derivative in updating the position value. We don't use derivative information.
Okay.
Yes.
So can you tell me how many nature-inspired optimization algorithms are available by today till now?
There
Any
are
idea?
hundreds of meta heuristic methods which are invented by the various mathematicians. So there are hundreds of methods like artificial bee colony, cuckoo search method, cross entropy methods, covariance metric adaptation evolutionary methods, differential evolutionary methods, genetic algorithms, harmony search methods. So impulse methods are there.
So what do you think, which one is the best one till now?
I cannot say any method is a best method. As I said in the last slide, as per the
Yeah,
no
no
free
free
lunch
lunch,
theorem.
no free lunch
Yes.
theorem. Yeah.
Yes, so the average performance of all methods remains almost constant. But I would like to say that if your problem size is small, if it means if your problem consists of less than I would say 30 variables or 50 variables, then all methods will give the almost same answers. But as the size and complexity of your problem increases, it means if your problem consists of lakhs of variables, in one of my competitions which I won in that competition, the problem consisted of 9 lakhs equations and 3 lakhs continuous variables and 3 lakhs discrete variables. So in this case, in which the number of variables and constants are very high, then the performance of all methods will be different, and we have to find which one will give better answers as compared to the other answers. So as a result, GECO, WCCI, World Congress on Computational Intelligence, and Computational Intelligence Society, that is CIS, and IEEE PES, Power and Engineering Society, every year organizes such type of competitions on optimizations. And in that competitions, the real practical problems, optimization problems, have to be solved by the participants. And in that, yes, you can participate and you can check the performance of your proposed algorithms. But yes, in a final, you cannot say that my algorithm is the best one. Yes, you can say that for this particular problem, suppose cost minimization, my algorithms outperforms with respect to the some other tested 10 algorithms or 20 algorithms. But you cannot make the statement like my algorithm is the best one. You cannot say like that.
So what is the exact name of your algorithm?
Yes, I had proposed many algorithms in last competition, which I got the first rank. In that case, I had hybridized two algorithms. Those are cross entropy methods and covariance metric adaptation (SMIEEE) algorithms. In the last competition, I had proposed enhanced velocity differential evolutionary particle sum optimization. It was the hybridization of a PSO. Then I introduced the enhanced velocity step length equation, and I merged the concept of differential evolutionary methods. In 2017 competition, I had used the concepts of Levy flight in updating the step length of the possible solution, and that algorithm was a Levy differential evolutionary particle sum optimization. So I had hybridized many algorithms and I had combined them into a one algorithm. It means I hybridized the functionalities of almost 5 to 7 algorithms, and I have clubbed them into one. So
Okay,
yes,
so
hybridization
can you tell
is necessary for improving the convergence of the basic algorithms, because basic algorithms convergence is not perfect. Of course, for small scales you can use the basic algorithms. Otherwise, for large scales you have to hybridize the algorithms, and you have to take the best functionalities of algorithms and you have to club them into one. Yes.
So can you tell the gaps available now in this area?
It means in which in area of optimization?
Nature inspired optimization. Yeah.
Yes, yes.
Yeah.
So if you consider any real practical system and if you refer any paper, right, and you can see the answers or possible solutions, you can see the optimized values of the cost. But who knows that the optimized value of cost is not the optimum answer. It may be the sub-optimum answer, and there are also the chances for improving that answer, and you can apply your algorithm to get even the better answers. So yes, you have to see the papers in your field and you can apply your algorithm.
Sir, my
to
last
get
question.
one.
Some other persons are also waiting.
Yes.
So, may I have your mobile number? I want to communicate more about it with you. I am in Delhi University and
Ah,
I am working on it. So, I want to communicate about it. So, is it possible to have your mobile number?
94278
Yes.
94278 56115.
Thank you, sir. Thank you very much.
Thank you. Yes, any question?
Sir,
Yes, yes. 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 Yes, termination criteria should be written when you write a program. And as I mentioned earlier, if the two consecutive values of the functions of the global based particles are almost same, it means there is no difference between the two consecutive values, then you can stop. Or else, when the two consecutive values of the based values of x, it means g based particles. If two consecutive values are same, then its difference is 0. Then you can stop. Or else you can define the number of iterations like 10,000 or 50,000 or 1 lakh, right? So after 50,000 you can stop the iterations and you should obtain the answer within 50,000 iterations. For large scale problem you can take 1 lakh iterations as well, and it will consume lots of time, in minutes or in hours or in days. In one problem in which I mentioned that we had to solve the problem in which 9 lakhs constants and 3 lakhs discrete and continuous variables were available. That problem required in a normal PC almost 5 days to solve the problem. It was a planning problem. So there was no constraint concern, but it required almost 5 days to solve that sum. Yes, any question? Next.
If some constraints in the problem, then how will be computed velocity and position?
Yes, same equation. We are incorporated the constraints in the object function. Right? This equation, a new function plus this constraint violation square. So you are augmented, you are append this function as well as this function with the original function. So we are using the same equations, no change.
Then, sir, how to choose the value of random R and C?
Yes, in PSO, C1 and C2 can be taken as 2.1 and R is a random number. So you have to randomly generate the number in programming. So in MATLAB, if you write rand, then the random number will be generated between 0 to 1.
Is PSO good par with other optimized algorithm like GA or ACO?
See, every algorithm is problem specific. We cannot say that I cannot make any generalized statement. But if you solve particular problem and if you get the answer, then in many cases you will find that the PSO gives better answers than genetic algorithm. Right? If you use the primitive genetic algorithm, in genetic algorithm due to the mutation, it consumes lots of times. It requires large computation time. Right? So in that case, the PSO gives better answers than genetic algorithm. Right? But I would like to say in most of the optimization algorithms, lots of research has been already carried out. So you can use the improved versions of all these basic methods. So you can get the perfect optimum answers.
Sir, can we have minimization and maximization of different variable in same objective function?
Yes, it is called as the multi-objective optimization. It is a yet another big ocean of the optimization field. In multi-objective optimization, we are simultaneously optimizing more than two objective functions, two objective functions or three objective functions, and it may happen that both the objective functions are conflicting in nature. We want to maximize one objective function, and simultaneously at the same time we want to minimize the other objective function. So it is called as the multi-objective optimization. Yes. And if we can use the PSO methods, all meta-heuristic methods can be used to solve the multi-objective optimization.
And at last, sir, can we derive MSE and set a termination condition?
It means mean square error.
Yes, sir.
Yes, sir. You can make the objective function. Yes, sir. Objective function is a user-defined function, right? You have to define the objective function, and you have to define the constants. You have to define the variables. So yes, you can use a MSE, mean square error, to optimize the objective function.
And sir, kindly mention some reference from we can study these multi-objective functions.
Yes, yes. In a Google, yes, Professor Kalyan Moy Deb has done excellent work in the field of multi-objective optimization. So in Google, just type KDEB, K.DEB, Kalyan Moy Deb. And in the website of Kalyan Moy Deb, sir, MATLAB codes are available, various optimization, multi-objective optimizations are available. So you can study them. Also, Professor Ankur Siha of Indian Institute of Management, Ahmedabad, has done excellent work in the field of bi-level optimization. It is a different class of optimization. So, in Google, just type Ankur Siha, it's a website, and study material, mat code, etc.
I think the doubt has been clear of the participants. If
Any?
any other participant has any doubt, then they can unmute themselves and ask.
Sir, will you be sharing video of this lecture?
Yes, yes.
Because
What is
the
the question?
programming part which you have explained is with only PPT will not be sufficient if we actually start working on it.
Yes, I will email you the MATLAB code to the Professor Vipin Yadav, and he will email you.
No, sir. The video lecture in which you have explained the code.
Video lecture. Okay, I will also share the
I
video
will
lecture.
answer that.
Thank you. Thank you. Thank you, sir.
Yes.
Hello,
Yes.
sir. May I ask one question?
Yes, yes.
Sir, if we hybridize one algorithm with hill climbing algorithm, and we are having as initial candidate solution, which we say initial population, we have taken suppose 50 participants, 50 solution. Then we will get, can we get 50 answer will be the 50 only, or only one minima or one maxima we will get, or we can get many solutions?
Yes, yes. You are initializing 50 particles. So corresponding to each particle, you will get f of x value. So you will obtain 50 f of x value. And from those 50 f of x value, you have to find which one is the best answer, which one is the minimum answer. And that
Sir,
is the...
after getting this f of x, then we will apply local search algorithm because we have to hybridize it. So we apply hill climbing. Then we will get 50 answer, or we get just one answer?
It depends upon your nature of algorithm, how you update the step length. But in general, if you are using the 50 particles in hill climbing, right?
Yes,
of course, corresponding to each particle, you will obtain f of x values. Then you have to apply some rules and find out which one is the minimum, and then update the value of x, and then compare, and then ultimately your aim is to find the best minimum answer out of all possible 50 answers.
Yes,
so it depends upon your how you write your algorithm.
Okay, sir. Thank you so much. Thank you.
Sir, there is one more question.
Yes, yes.
How are the penalty function applied in engineering design problems?
Yes, depend. Yeah, in any given problem, you are suppose this is the problem, right? So these constraints are there. So you have to augment these constraints with the objective functions. But you have to define these constraint functions depending upon your basic knowledge, right? Or the knowledge which you gain from the book or from some vendor will give you the constraints. Then you have to formulate this equation. This is the task of yours. You have to define these constraints. Nobody will give you these constraints ready-made. Of course, and you have to define these objective functions. Nobody will give you these objective functions. And yes, this is the task of engineer. We have to define the constraint functions. We have to define the variables. Of course, the first step is to define the variable, which are the optimization variable, which are to be optimized. Then you have to define the constraints from the design data, which task we want to optimize, right? And finally, you have to define the objective functions. So optimization process involves 3 steps: identification of the variable, design of the constraints, and design of the objective functions. So nobody will ready-madely give you the all these 3 steps.
Okay, I hope that query has been answered. So since we are ahead of the time scheduled, I would
Sir, one question.
say thanks to
Yes,
sir.
yes, yes.
Ma'am,
Sir, one question.
Yes, yes.
So, how 2 algorithms can be hybridized, sir?
Yes, yes. It depends upon your knowledge.
Okay.
You have to study number of algorithms, then find out the advantages or say some strong points of the algorithms, right? And try to get the strong points of those algorithms and try to feed those strong points in the another algorithm. So yes, it's a area of research. Once you have many algorithms that way, then you can find out which are the strong points and how they can be incorporated in some algorithms. Then only you can hybridize those algorithms and you can obtain the better optimum answers for the specific problem. But yes, I would say hybridization is must if you want to improve the optimum answers of your design problem or engineering optimization problem. If the problem is very complex, non-linear.
Yes, sir.
Yes.
Sir, is there any difference between
Okay, I want
ensemble
to
approach
interrupt,
and
ma'am.
hybridization approaches?
Ma'am, hello.
Please repeat the question.
Is there any difference in between ensembled approaches and hybridization approaches? Do we get different results in this both the cases?
Ensembled, it means it means they are both the hybridized approach, right? And yes, it depends upon the problem which you are solving, right? So you cannot say this one is better or this one is better. It depends upon the problem that you are going to solve.
Actually, I have gone for ant colony optimization and particle swarm optimization. Both the techniques have gone for hybridization. Now I just want to go for some other concept like spiking neural networks. I want to combine these 3 together to get a better results. Can we go like that?
But why do you want to club ACO and ant colony optimization in PSO?
Predicting, actually my domain is software engineering, sir. So I just want to go for hybridization of these 2. Ant colony and particle swarm.
But there is some definite logic, justifiable answer. Why do you want to merge them? And which part of ACO would be merged in PSO or which part of PSO would be merged in ACO? That should be justifiable. It means you should get some good results. But before getting the good results, there is some justification. Are you modifying the equations of PSO or are you going to modify the equation of ACO? This is the
Okay.
Yes, that you have to, yes, I want to say that in a PSO, as I told earlier, in inertia weight, the inertia, it means velocity is gradually decreasing. But in a real optimization, in many times, the velocity is adaptively increased or decreased. So it is not always gradually decreasing. In a covariance metric adaptation evolutionary strategy, that is CMEES, the step length is adaptively increased or decreased, or it is kept constant, and as a result I got better answers as compared to the other meta-heuristic methods. So you have to search for those good methods, right? I have given just simple example, right? So step length should be adaptively changed depending upon the some set criteria.
Okay. Okay, sir. Thank you.
Yes, any question?
So, sir, I think there will be a lot more questions with the participants. We have already shared the contact details as well as email. Those who have more queries can mail to sir, or sir has already shared.
Hello? Thank you. Thank you for giving me an opportunity, and it was a nice session, and it was nice other. Thank you.